Over 252 million years ago, the world as it was known teetered on the brink of oblivion, not by the hand of an asteroid from the far reaches of space, or by the clash of titanic creatures, but by forces deep within the planet itself. This was the time of the Great Dying, the greatest extinction event in Earth's history. A calamity so sweeping that it eradicated nearly all life, both in the oceans and on land. Today, the tale of this ancient catastrophe serves as a warning and a lesson, echoing across eons to our modern age. Imagine the world in the late Permian period. The continents, fused into the mighty supercontinent Pangaea, sprawled from pole to pole, an immense expanse of land surrounded by the endless Pan-Thalassic Ocean. The geography was both a marvel and a curse. Where today continents are separated by bodies of water that moderate climate, Pangaea's vast interior lay far from the tempering influence of the sea, creating extreme and often inhospitable environments. Yet despite these challenges, life flourished in astonishing diversity. The land was draped in dense forests of towering tree ferns and ancient gymnosperms, the predecessors of modern pines and firs. The undergrowth was thick, home to strange insects and primitive reptiles. Among these early creatures soared Meganeura, a dragonfly-like insect with an awe-inspiring wingspan nearly the length of a human arm. The air, rich with oxygen, buzzed with life. Beneath the waves, the oceans teemed with creatures that seem alien by today's standards. Ammonites, spiraled, shelled relatives of the squid, spiraled through the water alongside early sharks and armored fish. Coral reefs, though unlike the ones we know now, flourished in the warm, shallow seas. The Earth was in the midst of a golden age, a time of prosperity and abundance. But as the Permian period drew to a close, the climate began to shift. What had been a humid world became increasingly arid. Temperatures soared to extremes, especially near the equator, where the land became a blazing furnace. Some areas reached temperatures as high as 74 degrees Celsius, an unlivable heat for most life forms. The vastness of Pangaea meant that many regions were cut off from the moisture and moderating influence of the ocean, turning them into deserts. Mountain ranges blocked the flow of moist air, creating rain shadows and further desiccating the landscape. Ecosystems began to falter under the strain, but these challenges were only a prelude to what was to come. The cause of the Great Dying was not immediately apparent to those who would study its aftermath hundreds of millions of years later. For a time, scientists wondered if a massive asteroid impact, similar to the one that ended the reign of the dinosaurs, might be to blame. The evidence was tantalizing. Traces of rare isotopes and peculiar carbon structures in the rock layers of the period hinted at an extraterrestrial event. But as more data came to light, another, more terrifying explanation emerged. In the heart of Siberia lies a vast expanse of ancient volcanic rock known as the Siberian Traps. Here, one of the largest and most sustained volcanic eruptions in Earth's history took place. Over a span of hundreds of thousands of years, volcanic fissures spewed forth unimaginable volumes of lava, covering an area 2/3 the size of Europe. Imagine, if you can, a sea of molten rock engulfing the entirety of the United States, layering it in a blanket thicker than the tallest skyscrapers. But it was not the lava alone that changed the world. The eruptions released over 200,000 gigatons of carbon dioxide, sulfur, and other toxic gases, flooding the atmosphere and altering the climate on a global scale. Sulfur aerosols and soot rose into the sky, reflecting sunlight and plunging the world into a prolonged volcanic winter. Darkness fell over the land, and temperatures dropped, only to swing wildly as greenhouse gases took hold, driving global warming to catastrophic levels. The air itself became toxic. Oxygen levels plummeted from a high of around 30% to as low as 15%, suffocating the land's inhabitants. Forests burned in wildfires ignited by the relentless heat, sending smoke and ash billowing across continents. Even creatures far from the eruption's center could not escape the effects. The very chemistry of the atmosphere had changed, and with it, the fate of all who breathed its poisoned air. While the land was scorched, the oceans fared little better. The warming atmosphere heated the surface waters, disrupting the delicate balance of life beneath the waves. Oceanic currents slowed, and the water became stratified, layered in such a way that oxygen from the surface could no longer reach the depths. Vast regions of the sea became dead zones, where life suffocated in anoxic blackness. Meanwhile, the relentless influx of carbon dioxide was absorbed by the oceans, forming carbonic acid and driving pH levels to dangerous lows. Shell-forming creatures, like the once abundant ammonites and corals, found themselves unable to survive in the increasingly acidic waters. Whole ecosystems collapsed, and with their fall, the ocean's ability to sustain life was crippled. Amid this devastation, some have speculated on alternate or additional culprits. Perhaps a nearby supernova bombarded Earth with cosmic radiation, destroying the ozone layer and allowing deadly ultraviolet rays to sear the surface. Fossil records from the time show evidence of mutations in plants, possibly the result of intense UV exposure. At the poles, radiation levels may have soared to 50 times what we experience today, making survival even more tenuous. There are even theories of hypercanes, super hurricanes spawned by ocean temperatures as high as 50 degrees Celsius. These monstrous storms, with winds exceeding 800 kilometers per hour, would have torn apart forests and stripped the land bare, leaving no refuge for any creature caught in their path. The air pressure within such a storm would be so low that a human would perish in moments, never knowing what had struck. Yet the most chilling revelation is that this extinction did not happen in a single cataclysmic moment. The fossil record reveals a series of extinction pulses, waves of death that swept across the globe over thousands of years. Each wave brought new destruction, erasing species that had survived the previous onslaughts. Some regions may have offered fleeting sanctuary, but none could withstand the full measure of the planet's fury. When at last the eruption ceased and the skies began to clear, the world that emerged was almost unrecognizable. Of all marine species, 96% had vanished. On land, 70% of vertebrates were gone. The very fabric of life, families, genera, entire evolutionary lineages, had been shredded. Only the hardiest, most adaptable organisms survived to carry the torch of life into the future. Those that did survive were often the small and the burrowing, creatures able to escape the worst of the surface conditions. Certain amphibians, reptiles and plants clung to existence, eking out a living in the altered world. These survivors would become the ancestors of the life forms that would eventually repopulate the planet, setting the stage for the rise of the dinosaurs and the dawn of the Mesozoic era. How do we know the details of these ancient events? The answer lies in the rocks beneath our feet. Through the science of stratigraphy, geologists decode the layers of the Earth, each stratum a page in the planet's vast history book. Early pioneers like William Smith and Roderick Murchison mapped the distribution of fossils and rock types, identifying the boundaries between epochs. It was Murchison who, exploring the wilds of Russia, first recognized the unique characteristics of the Permian period, giving a name to the era that ended in such spectacular destruction. At the boundary between Permian and Triassic rocks, the signs are clear. Fossils disappear in a sudden, dramatic break. Chemical signatures shift, with spikes in carbon and sulfur pointing to environmental upheaval. Sediment layers reveal evidence of wildfires, acidification, and mass die-offs. These clues, pieced together from around the globe, form a tapestry of devastation and, ultimately, renewal. The story of the Great Dying is not just a tale of ancient tragedy. It is also a mirror, reflecting the vulnerabilities of our own time. The forces that drove the Permian extinction rising greenhouse gases, ocean acidification, disruption of habitats, are all too familiar today. Human activity now releases carbon into the atmosphere at a rate that rivals, or even exceeds, the volcanic emissions of the Siberian traps. The consequences are already visible. Melting ice caps, warming oceans, the bleaching of coral reefs, and the decline of countless species. But there is a vital difference. The ancient catastrophe was a natural event, the result of processes beyond the control of any living creature. Today, we hold the reins. Our actions determine the fate of the biosphere, for better or worse. The Great Dying stands as a warning, a testament to the fragility of life and the power of the earth to wipe the slate clean. Yet if there is hope to be found in this story, it lies in the resilience of life itself. After the ashes settled, evolution began anew. Over millions of years, new species arose to fill empty niches, and the world was once again cloaked in forests and teeming seas. The survivors of the Great Dying gave rise to the dinosaurs, and ultimately to the mammals, including ourselves. In the end, the lesson of the Permian extinction is twofold. It is a reminder of the awesome forces that shape our planet and the need for humility in the face of nature's power. But it is also a call to stewardship, a plea to recognize our responsibility to the world we share with countless other forms of life. We may not be able to prevent every cataclysm, but we can choose the path we walk. We can learn from the past, adapt to the challenges of the present, and strive to build a future where life, in all its diversity, can continue to flourish. The story of the Great Dying is not just a record of death. It is a testament to survival, renewal, and the enduring spirit of life on Earth.